This is the credit recovery video for Unit 10, and we will be solving systems. Number 1 says to solve the system below using graphing. And so when I graph, I usually like to have this in slope-intercept form, so y equals mx plus b. And I notice that this first equation is not. So I'm going to go ahead and solve that for y. So I'm going to subtract 3x to the other side. And I'm left with negative y equals negative 3x minus 4. Again, I want that to be a positive y, so I'm going to divide by negative 1. I'm dividing everything by negative 1. And I'm left with y equals positive 3x plus 4. So now I have both of my equations, and I notice that they're the same equation. I still am going to graph them, so my slope is 3, and my y-intercept is 4. And if I were to graph both of them, I would graph the same exact line, so they would overlap each other. And I'll graph the other one in the pink or the red color. Okay, and I notice that they are the same line. If they are the same line, the solution is going to be infinitely many solutions. Again, because they're the same line, they overlap at every single point, so it's going to be all of the points. Number 2 says, two lines have given equations. What point satisfies both equations? And this one tells us to solve using matrices. So the first thing that I'm going to do is go ahead and set up the matrix. Okay, and we're going to use the coefficient in front of the variable. So I have 2. That's a negative y, so negative 1. And that equals 1. And then I have a 3 in front of my x, and again another negative y, so negative 1, and that equals negative 6. Okay, and this matrix is a 2 by 3. And I'm going to go ahead and type that in the calculator to solve. So make sure you turn your calculator on. Okay, the first thing that we're going to do is we are going to go to second matrix. We're going to go over to the math tab, and then we're going to go up until we see b. Okay, so B is right here, it's RREF, and we're pressing enter. Okay, now we're going to go ahead and let this solve our matrix for us, but we have to first input it. So I'm going to click alpha zoom, and I want to make sure that this is a 2 by 3. Okay, luckily for me it already says 2 by 3, but if it didn't, you would just have to go over and select and make sure that you have 2 rows and 3 columns. Okay, once you have that selected, you're pressing enter on OK. And we're going to go ahead and type it in exactly how we wrote it. So 2, arrow over to 3, sorry, not 3, that should be a negative 1. And then arrow over to positive 1. And then I'm going down to the bottom and typing 3, negative 1, and negative 6. Okay, make sure that you use negative signs and not the subtraction sign. And then also double check to make sure that your matrix looks the same as what you typed in. So 2, negative 1, 1. 3, negative 1, negative 6. Okay, once you have that typed in, you're pressing enter. And when it says 1001, okay, that's telling you that you did it correctly. This one is for your x and that one's for your y. And so your solution is going to be the last 2 numbers. And here we have negative 7 and negative 15. So that's my solution. It's given it to me in the x comma y. So negative 7, negative 15 is the solution to both equations. If I went too fast on those steps, make sure that you pause the video or rewind it and go back so that you can get those calculator steps. Number 3, solve the system below, and this one wants us to use graphing. So again, I'm going to make sure that they're both in y-intercept form. So x plus 2y equals 10, I have to go ahead and solve for y. So I'm going to subtract x over. So I'm left with 2y equals negative x plus 10. And then I'm going to divide by 2. Make sure that you divide everything by 2. So I'm left with y equals negative 1/2 x plus 5. So I have my two equations. Okay, and I notice that both equations have the same slope. Now we could type these into the calculator and look at it, but these are pretty easy ones to do by hand. My first one has a y-intercept of 5 and a slope of -1/2. And the second one I'm going to do in this blue color has a slope intercept of 3 and the same slope. If I didn't already catch it by looking at the slopes, I know that these two lines are parallel. Okay, and when they're parallel, that means they will never touch on the graph, and so therefore there are no solutions. Okay, there's never a point that's going to work for both equations. Number 4, some values for two linear equations are shown in the tables below. What is the solution to the system of equations represented by the tables? Well, first we have to remember that a solution is whenever they have the same point. So it's something that works for both equations. So just looking here at the graph, I'm going to go through and check the points. And I notice that they both have the point -2, -4. Okay, so that means if I were looking at a graph at -2, -4, okay, those two lines would intersect at that point. So that means that -2, -4 is the solution to both. Number 5 says solve the following system below using matrices. Okay, this one is a little different from our last one because if we look at that second equation, it's not in the same order as the first one. Our y value is first and our x value is second. So I'm going to rewrite this to say 4x minus 3y equals -3. So now that everything lines up, sorry, that doesn't equal -3, that equals 6. Now I can go ahead and write the matrix that I'm going to type in. So 5, -9, -3, and 4, -3, 6. I'm typing that into the calculator. So again, going through those steps, second matrix, arrow over to math and go up to B. Now I'm going to click alpha zoom so that I can type in my matrix. Make sure that your rows and columns, remember rows are horizontal, columns are up and down, they're vertical. So 2 by 3, and I'm going to select that and type it in. So 5, -9, -3, and the bottom row I'm typing in 4, -3, and 6. Okay, once that's all input and you know that it matches up, I'm pressing enter. And 1, 0, and 0, 1 tell me that I did it correctly. And I get 3 and 2. Remember, they're in order of x and y. So my solution is 3, 2. So that is the solution that satisfies both equations. Number 6, a math test has 25 problems. Some are worth 2 points and some are worth 3 points. The test is worth 60 points total. If x represents the number of 2-point problems and y represents the number of 3-point problems, which system of equations could be used to solve to find the number of how many 3-point problems are on the test? So again, we're not solving this one, but we're showing which equations could be used to solve. So the first thing that I know is there's a total of 25 problems. So off the back, I know that the 2-point problems plus the 3-point problems equaled the total number of questions. So I can automatically cross out the ones that say x plus y equals 60. Now I'm going to go ahead and keep going, okay? And the next total that I have is 60 points. So that's the total points possible. And so some are worth 2 points and some are worth 3 points. So I need to figure out if x is worth 2 or if y is first 2. So it says if x represents the number of 2-point questions. So I'm going to say 2 points times the number of questions, and y represents the number of 3-point questions, so 3 times y, that equals 60. So looking here, the only one that has 2x would be C, because this one says 3 times the 2-point questions and 2 times the 3-point questions, which we know is wrong. Number 7, Christy made 48 cookies. The number of chocolate chip cookies she made was 3 more than 3 times as many sugar cookies. That's a lot. Which system of equations below can be used to find how many chocolate chip cookies, so C, and sugar cookies, S, Christy made? So we know in total that she made 48 cookies. So chocolate chip plus sugar cookies equals 48 total. So let's see if we can eliminate any of them. I think that we can eliminate S minus C because we didn't subtract any. We made 2 different types of cookies. And I think that we can also eliminate C because S plus C should not equal 3. Now let's look at the next equation. So A, the first one, and D, the first one, check out. The next thing we can look at is this tongue twister right here. The number of chocolate chip cookies she made. So chocolate chip cookies equals, so I'm going to say C equals, was 3 more than. Okay, more than is a turnaround word, so I'm going to have plus 3 at the end. 3 times as many. So 3 times as many is going to be multiplication. So I'm going to say 3 times the sugar cookies. So that gives me 3S plus 3. And the only answer choice that I have left now is 3S plus 3. So A is going to give me my systems that will help me solve. Number 8, the equations of 2 lines are 4x minus y equals 5 and y equals negative 2x plus 1. What is the value of y in the solution for this system of equations? And they want us to use substitution. So I'm going to use a little work to the side. I'm going to substitute y equals negative 2x plus 1 into that equation. So 4x minus negative 2x plus 1 equals 5. Okay, using don't call me after midnight, I do need to distribute, so I'm going to distribute that negative inside. So 4x plus 2x minus 1 equals negative 5. I'm going to now combine like terms, and I'm left with 6x minus 1 equals 5. I don't need to move variables, but I will add or subtract, so I will add 1. And I get 6x equals 6, so x equals 1. Okay, now that I know that x equals 1, I can go ahead and plug that in because I want to solve for the value of y. So I'm going to say y equals negative 2 times 1 plus 1. Negative 2 times 1 is negative 2, so negative 2 plus 1 equals negative 1, so y equals negative 1. Number 9, what does it mean if 4, 1 is a solution to the systems? So if that is a solution, so 4, 1 is a solution, so what does that mean? So here it says makes at least one equation true. Well, that can't be right because it's a solution to both equations. So that means it makes both of the equations true, which is B. Okay, it makes neither of the equations true. Well, if it didn't make it true, it wouldn't be a solution. And it makes exactly one of the equations true. We know that's not true, so B is our answer. And there's no more questions on here. Again, if I went too fast or you need to go back over something, please pause it and rewind it.